anything that you don't already know how to do in any of your classwork. What I'm gonna do is just kind of go through and give you guys, it's kind of everything you already know. Thank you, sir. It's kind of everything you know, like distributing and canceling and variables on both sides, all mixed into a variety of different problems. No, I don't expect you to get all these done today, but you should be able to get a pretty good chunk, at least the first couple pages done today. So what I'm going to do, instead of doing like notes, I'm going to give you just some pointers, some suggestions, because you're not doing anything new. You're just kind of putting it all together in one problem. So focus, and you'll notice I also put tons of video links throughout this assignment also to help you, like give you some hints and strategies and stuff too. But one thing I wanted to point out, so problem number 1, the way that you're probably gonna see most people, like if you look in a textbook, the way they're probably gonna tell you to do number 1 is, what does it mean with the 2 sitting there next to the parentheses? What does that mean? Add, subtract, multiply, or divide? Multiplication, right? So if you were to look in a textbook, and 99% of teachers in America, I would say, would probably tell you, you can't combine the 2 and the negative 2. Even though they're on the same side of the equal sign, you can't combine them because that 5n and that minus 2 are like trapped in those parentheses together. So what most teachers and textbooks will tell you to do is take that 2 and distribute and do 10n minus 4 is equal to negative 84. And then you're going to cancel out the minus 4 with a plus 4. Just like a regular 2-step equation, right? So that would be negative 80, divide both sides by 10, n is equal to negative 8. So if you do it that way, you're going to get it right, barring any like little mistakes. Now, I personally am a fan of working, I don't want to say that speed is the most important thing, because it's not. That I am thinking about some of you guys in your future and like taking your ACT, for example. And we've already talked about how much time do you get to do an ACT problem on average? You get 1 minute. So there is something to be said about working as quickly as you can. And so this is a strategy that you could utilize. Sometimes it doesn't make sense to do it this way, but for this problem it does. Because notice how the 84, or negative 84, I should say, is an even number, right? Which means it's very easily divisible by 2. Kind of a shortcut could be to, instead of distributing the 2, just take both sides of the equation and divide both sides by 2 to cancel out that 2 from the get-go. Since the 2 and the 5n minus 2 are all like one unit, you can actually divide off that 2. A lot of you guys with really good number sense, way better number sense than I had when I was your age, could probably do this step in your head. And that 2 is going to cancel, and it's of course going to leave you with that 5n minus 2 is still going to be there. And then on the right-hand side, 84 divided by 2 would give you negative 42. Now, I would not do that if instead of 84, if this were like 75 or something that's not an even number, I probably wouldn't utilize that strategy, because you know how I feel about fractions and decimals, and that's what that would do. But especially since it's an even number, instead of multiplying, just divide everything out in that one step. And then as you can see, you're still going to get exactly the same answer. You're still going to get negative 8. It's just a tiny bit faster. So when you are in a situation, high stakes testing that really is more important than it should be, in my opinion, and you need to save time, looking for little ways to save yourself time like that are a good idea. But again, if that 84 had been an odd number, I probably wouldn't do it that way. So anything in section 1 of this assignment, this is a good strategy. Either of these 2 strategies is a good one. You could either distribute, or you could cancel out that number on the outside by division. But again, check to make sure that this will divide easily by that. Otherwise, that strategy is not a good one. You should just stick to division. And if this strategy didn't make sense to you and you're like, what? Don't worry about it. If you distribute, you'll get it right as long as you do it correctly. Okay, so that takes care of all of the things in section 1. They're all very similar. And again, I threw some videos in there for examples if you need them. So section 2, there's a couple problems I want to talk about. So the first thing is, this is literally the 17th year that I've taught this exact same topic. So I know by now exactly what mistakes kids are going to make. One of the mistakes that I frequently see is kids doing something like this. Okay? Why can I not combine those two things? Because it's just four, not four. Right, they're not like terms. Okay? And then I also see some people, which I totally understand, some people will try to do this, and the reasoning makes sense. They're like, hey, those are like terms, and they're on the same side of the equal sign. Let me just combine those. You can't do that either because that 4n is like trapped, thank you, inside of those parentheses. And until you get the 4n out of the parentheses and away from that 4, you can't combine those like terms either. So this is definitely going to be one of those times when you're probably just going to want to do your distributive property. It doesn't make sense on this problem to just divide by 4, because if you do decide to divide, it's not wrong for you to do it that way, but man, it would be a lot of work. Because if you divide that by 4, you've got to divide everything by 4, and none of those turn out to be a whole number or anything, so I wouldn't mess with any of that. This one, I would just do good old-fashioned, start off with distributive property right from the get-go. So I would do 16n plus 4. And I know especially you bright kids don't like to write things down, especially as it gets more complicated and more steps to solve. The more you try to do it in your head, the more likely you are that you're going to screw up. So take the extra half a second it takes to write it down and make sure that you're doing it correctly. So now that I've got that out of the parentheses and I've got like terms on the same side of the equal sign, now I'm going to combine those like terms. So it would help if I actually added those like terms. I'm going to bring everything else down. And finally, I'm going to subtract 4 from both sides and divide by 19 so that I get, I think it's 7, yeah. N is equal to 7. So for the second section of the classwork, I really think the best way to do it is just do your distributive property and then combine anything. The last thing I want to warn you about is something similar to number 9. I'm going to zoom in here for a second because a lot of people will decide, oh, look, they're on the same side of the equal sign, and this time they're like terms. So can't I just put them together? The answer to that is, well, I wrote it in red. What do you think the answer to that is? No. Here's why. And this is actually a mistake that haunts kids in a variety of different applications. This just happens to be one of them. This means multiplication, right? When the 3 is sitting next to the parentheses. And then, of course, obviously, this means subtract. And please excuse my dear Aunt Sally, in order of operations, do you multiply first or do you subtract first? You multiply. So if you do 8 minus 3 first or negative 8 minus 3, you violated the order of operations and you won't get the answer correct. So even though it's tempting to do that subtraction first, because they are like terms and they're on the same side of the equal sign, you cannot do that. You're going to once again want to do your distributive property, which when you do that, they get you negative 6 minus 24n. I'm going to bring down everything else. The other thing that I see kids have a tendency to make as a mistake is that they see these two things sitting next to each other, and they think it means that they need to multiply them, and it doesn't. If there were parentheses in between, like if there were another set of parentheses by the 8, that would mean multiplication, but there aren't, right? So when you go to combine those two, you simply just combine the two negatives together.
Dr. Liz, where is this class kicker?
Oh, do you not see it on? Right. So where was I? Oh, yeah. So this one, you would obviously just go back to a 2-step equation, okay? So on the second page. So those two examples get you through everything that's in section 1 and section 2. Starting in page 13, those are the type you learned how to do yesterday. So first mistake I see a lot of kids make is say, oh, well, those are like terms, so I'm just going to combine them. However, we know they're not on the same side of the equal sign, so we can't combine them. So that is why we learned how to do what we did yesterday, where you just choose either variable, doesn't matter which one. You guys are going to see that I pretty much always choose the smaller variable, because if I do minus 3m on both sides, that means I'm going to have a negative number. And when I was in your shoes, I used to make a lot of mistakes with my negatives. So even though you can really start off by canceling out whatever you want, I'll typically start with the smaller variable. Yes, ma'am. So you just need to do it. You can do it on dry erase boards or something. It's fine. Okay. So if you subtract 2m from both sides, that'll leave you with the 1. 3m, take away 2 m's is going to leave you with 1m, which is really just the same thing as an m, minus 5. And then I'm just going to cancel out that minus 5 with a plus 5 on both sides. So as all these examples, you can see you're not learning anything new today. You're just kind of putting together everything you already know how to do. Two on page 4. So if you do what you're supposed to do, where you distribute first, so we're going to do 7 times x. So this is on page 4 is where I'm doing this one. So if I do, so 7 times x, and I get 7x minus 14, then this one is negative 7 times x. And then plus 21. What is going to happen when the two x's combine? Because they're on the same side of the equal sign. So what's going to happen when that 7x and that negative 7x combine? Positive 7x and negative 7x. They're going to cancel each other out because it's 7x take away 7x. So those are going to cancel. And then if you combine the numbers that are on that side, so if you do negative 14 and positive 21, so the x's are going to cancel each other out. So then you need to combine the 14 and the 1. So look, you're going to get this equation. So the variables canceled out, and you've got an equation that's false. So that means that because of the way this equation is set up, there's actually not a value that will make this equation true. So we need to say that this one has what we call no solution. Because the variables, the way that equation is set up, you've got that positive 7 and that negative 7x. They're going to cancel each other out, and that's going to leave you an equation that is false and no variables either. So in a special case like that, you're going to see no solution. Number 3 is kind of the same idea, but it's got a different spin to it. So number 3, I'm going to do the same thing where I am going to distribute. So 4n minus 4, and then here is 24 minus 4n equals 20. So once again, the n's are going to cancel each other out, but this time when you combine the like terms, you don't get an equation that is false, you get an equation that is true. So because of that, since the variables cancel each other out, it doesn't matter what value you put in for x. Like you could put in, what if x were equal to 2? Well, they're going to cancel each other out anyway, and you're going to get an equation that's true. What if you put in 12 for n or whatever? You could put any number in for n that you want, and that equation is always going to be true because the variable is just going to cancel itself out anyway, and it leaves you with a true equation. So variables cancel out, you get a false equation, you say that that has no solution. Variables cancel out, and you get a true equation, It doesn't matter what number you put in there, it's always going to balance out. So you actually could say one of two things. It depends on your algebra teacher, how they want you to say it. You could say option number 1, that it has an infinite number of solutions, because it does not matter what value you put in for x, or n, I guess, since they cancel each other out anyway. You could put, doesn't this sound fun? Just put numbers in for the variable all day long and just keep substituting it in there. Doesn't matter what number you put in there, it'll work. The other option in Algebra 2, you're more likely to use the second version, which is all real numbers. Yes, when you get to Algebra 2, you actually deal with numbers that are not real.